Alright boys, welcome to another video. In this video, day 4, Events of Code. Wow, they put 4 all the way up here. What is this gap? Not sure. So, I already read this first part. I'll tell you because I was at work. So I worked till midnight. So I can't solve it right away for this problem. But at least I read it before I go to bed. So now I just woken up. Now I can easily solve this. Oh shoot. So the idea is that, well, for the problem, you basically have numbers on the left and right side of these vertical bars. For every single curve, you want to find like the number of right numbers that exist on the left side. So first number you find, so if you find one number, this card is worth 1 point. If you find another one, it's worth 2, then 4, then 8, and so on. So it's like, if you found k numbers on the right that exist on the left, then the number of points it's worth is basically 2 to the power of k minus 1. So yeah, so while scanner that has next line, I probably want to answer variable. Scanner dot next line. Now again, with event of code, they're gonna give you informative input, but it's a pain to manually parse them. So the idea is that you don't. And let's say uh, and it's called history with string 2. Oh, this is so bad. Equals scanner. Okay, so equals the line. So I'm gonna split by the bar. And these should give me 2 strings. Yeah. Mhm. Winnings. So they call the left side winning numbers. So that's why I'm calling it winnings. Is equal to string 1 dot split. So I'm gonna split by these this time. And then I will do dot drop. So I want to drop the first 2 tokens, I guess. Drop 2 dot map. So I do map of its dot 2 int dot 2 hash set. This is the thing I like about Kotlin, is that you get to program this way. You have to manually program these operations using a for loop. And then the right side will be just called numbers equals string 2 dot split. So split by space. And then we just map it. I don't have to drop. So if I print winnings join to string, and I do the same thing for numbers, and I just separate each line by empty line. Hopefully I get the right data. Yeah. So far this has taken me 4 minutes. A return expression. Oh, screw off. I'm gonna solve a legal problem later on. Wait, what? Okay. Let me just see. String one, string two. So what are we getting? Okay, so let's print out the expression that's split. I kind of have an idea what's going on. So if I do dot drop two, what happens? Really? So now that gives me an empty array? Huh? Oh, because I'm supposed to separate by that. Card one. So, oh, that's annoying. What the heck? Okay, so I dropped the first two, right? So what the heck is this? Drop last one. So I need to drop last one because there's a low annoying empty space. So I think with this expression, this works. So what about this? So I split by that again, right? How do I filter out empty strings? I'm just gonna do this. Wait, why is it like that? That's so weird. Oh, that's gross. So what if I do filter it? Not it. It's that is not blank? Is that what I'm supposed to do? So, okay. So that's what I have to filter by. It's not blank. Dot map. So I need to put a filter here that is not blank. Dot map to int. Dot everything else. Okay. So this, I don't need it to be a hash set. I just need the first one to be. So for v in numbers, if windings dot contains v our scores equal to 0. Can I just do something like that contains that, like, can I see how many elements a hash map contains from another collection? Ask them. I'll look it up later in my spare time. Go on, plus plus. If scores equal to is bigger than 0, then we do answer plus equal to. Yeah, so I have to add up all the scores of every single game, card, thing. Do that. How? Math dot. Well, actually, I can just do one shift. Score minus one. Okay, should be a little bit faster. Whatever. So now we do this. Okay, what am I doing? Oh, shoot. I need to put this filter before. Holy frick. Okay. That's a little oopsie right there. So yeah, that should be correct now. 19135. Okay, part two. Wait. Only cause you to win more scratch cards equal to number of winning numbers you have. Wait. You win copies of scratch cards below the winning card equal to K? Wait. What? Okay, so I have to reading comprehension time. You win one copy. It says a little bit of a math going on. Okay, so if I win one, two, three, four, five. Okay. Okay, so then I'll have two copies of card three and four. No, but yeah, I have two copies of card two, then three. Okay. Yeah, so you don't want to. Now you get to a point where you don't want to do things naively. So this is going to be a little bit harder. So, what's the best way to tackle this? So for one copy, two, three, four. Yeah, so three instance. So wait, so how did? Let me think this through. So I have original copy three. I'm trying to figure out how to get four copies of card three. So I have one original. So you win a copy by card one, and it's just plus how many copies of. Why don't we? Hmm. Okay, I kind of know what to do. Let's okay, let's make it easier for myself. So it's gonna be array list of strings. So I'm gonna store the lines in a separate thing for now. I'm gonna comment that lines dot add line. Okay, I'm gonna separate this into nice code. So essentially what I want is a I'm gonna need an hash map for line in lines. So now I bring this parsing machinery here. So I don't need to print out the answer yet. Okay, I still want to keep the score actually. And now we have score for each card again. Events that put I and line. So I'm gonna do event thing. I'm gonna do the delta. I and then the value will be Event.merge. I want to add so basically I want to add the score to a certain key. So if a score doesn't exist in HashMap, it will default to the score. Otherwise, I will add a score upon whatever existed. So it would just be plus. There we go. For I in 0, I'll do line style indices. I will do events.put 0. We start with 1. Why is this giving a warning? What? Okay. So of I. So I'm doing this little trick with so if you do leak code a lot or some competitive programming, this events thing allows you to at any given point know how many copies of a card you have. F2. Okay, so that'll help me get 2. So if we start at 1, we have delta of 1, delta of 2. This is kind of, I'm just trying to make sure this is actually correct. Like the way I'm approaching this. I'm having troubles transitioning from 2 copies of card 2 to 4 copies of card 3. If I can resolve that, then it's pretty much game over. So, yeah, so 1 copy, 1 original. So I got copy of original, copy of, okay, so that would just be plus 1. And then 2 times that Okay. I found the transition, so I just pray it's correct. So it would be like why don't I just do it all in this loop? I just realized I can just do it all in here. What the heck am I doing? I don't need this. Right, so I plus plus. Okay, so here answer plus equal to delta times 4. Delta plus equal to events that get or defaults. I assume. I think it's delta. 39, so I overcounted. Dang it. Wait, that means can I just do events? Can I just do that? It will not crash. Yo, can I just do. Okay, never mind. That doesn't work like that. Okay. Let's see what went wrong. At every point, what's my delta? Yeah, but then that's also too low. Wait, that is literally the right one. How many total scratch cards do I end up with? So I have to add a delta? Is that what it's saying? Okay. Yes, this runs in linear time complexity. Well, minus the input parsing part, but I hope. Alright, GG. So yeah, the trick I use is that so I want to be able to say for every given point, for like, so obviously I process the cards from one to the last one, right? So that every given card in order, this is very important, in order, I want to know how many copies do I have of that card. So, well, for the programming purposes, I start at index 0, but let's say you start card 1. You know you have one copy of card 1. So then I say, so this event thing, essentially what it's saying is, so this is card 1, right? And this goes to like some other card. That's a really bad example. Let's call this card N. So let's say I have K winnings, right? So K winning numbers. K win numbers. So I know for the next K card, so I'll say like, this is K. So this is one copy. So number of copies I would have is like, so everything in this segment gets a +1, if that makes sense. And the way I represent this is I don't like go through every single card I win and add 1 to the count. I say this is +1. So this is called an event. So this event I add 1 to the count, and then at the end I do -1. So the effect is that everything in this range both have a +1, but it's just that I don't have to iterate through everything in here. I can instead represent as like deltas. Like if you want to learn more about this, try some LeetCode. But yeah, so delta means, so whenever I have a line, I parse it, right? Delta is the number of copies I have. That's, yeah, then just add up all the count of copies. And if you guys want the parse input, I parse it this way. So split by empty space. I filter all the blank elements because consecutive empty spaces, they don't get thrown out. Maybe there's a method for them, but whatever. So drop the first two for the winnings because after you filter out this empty space, you get these two tokens, the card itself and the number. And then I just map it to int to hash set. This same thing for string too, just a little bit different. But yeah, it's actually not that bad. Just have to think through it a little bit. So yeah, GG's.